guys, I just wanted to talk today about special right triangles. And there are probably a ton of videos out there on YouTube about special right triangles. And the reason why is because special right triangles, if you know these ratios and you have them memorized, your life will be so much better. These ratios are going to hold true forever, as so long as you have right triangles. And if you know them, then that just prevents you to have to do Pythagorean theorem or right triangle trig. So just know these, learn these. You'll thank me or whoever else told you to memorize them. Just super make your life 1,000 times easier. All right, so that being said, we're going to use right triangles, and you can always use a Pythagorean theorem, but this just helps it so you don't have to use the Pythagorean theorem. But let's just start with the 45, 45, 90 right triangles, and that is going to always have a ratio of leg times the square root of 2. And I'm going to use a square root of 2, but you can use any variable that you want. So let's just show that this works. So we know that with the Pythagorean theorem, a squared plus b squared equals c squared. But since a and b, they're isosceles and they're the same length, then we know that a squared plus a squared equals c squared. If we add them together, we get 2a squared equals c squared. We're going to take the square root on both sides, and we don't have to write a plus or minus because we're talking about lengths, so lengths are always positive. And you can tell once I simplify that I get square root of 2a. So c is always equal to square root of 2a, or a times the square root of 2. So that being said, we're going to go ahead and we're going to prevent ourselves from having to do the Pythagorean theorem every single time we want to solve for a 45, 45, 90 triangle, and we're going to use this. All right, so let's just start with the idea that if we had a square and we cut a diagonal through the square, we would have a 45, 45, 90 triangle. And if we wanted to know the length of that diagonal, we could do the Pythagorean theorem, or we could just say that longest length is going to be whatever that leg length is times the square root of 2. So that should just be 2 square root of 2. So it's really that simple. If you know the leg length and you know you have a right triangle, and if you wanted the hypotenuse, then you could just take that leg and multiply it by the square root of 2. And so I should get 3 square root of 2 so long as this was a right triangle. Again, doesn't work if it's not a right triangle, but since we have right triangles, no problem. In fact, you should get used to seeing your triangle oriented in many different ways, just so that you don't get thrown off. If this were an isosceles right triangle and you had 7 square root of 2, then you can just use 7 and 7 as the leg length. So notice 7 square root of 2 is longer than 7. So we know that that's going to be our hypotenuse length. Okay, so if you have the shorter length and you want to go and get the longer length, you're going to multiply by the square root of 2. But if you have the longer length, if you have the hypotenuse and you want to get shorter, you're just going to divide by the square root of 2. Pretty much it's that simple. So long as you have a 45, 45, 90 triangle, you're either multiplying or dividing by the square root of 2. So let's start with this one. I have the longest length, it's the hypotenuse, it's 10. I need to get shorter, so I'm not going to multiply by the square root of 2. I'm going to go ahead and I'm going to divide by the square root of 2. Now this might be ugly and you may not like it, and for sure it might be in not simplified form, but you can simplify this later, right? And so both legs are 10 divided by the square root of 2, and just as a review, to simplify, you can multiply top and bottom by the square root of 2, and that will get you 10 square root of 2 over 2. And again, that also takes a little bit more simplification because 2 can go to 10, and we have 5 square root of 2. So yes, those leg lengths are actually all 5 square root of 2. Okay, let's take a look at what we have. We have a square root of 2, so we have 5 square root of 2, 5 square root of 2, and times the square root of 2, we're going to go ahead and get 10. So what if we had 8 square root of 2 and 8 square root of 2? What would we get for a hypotenuse? We would just have to multiply 8 square root of 2 times the square root of 2, and you guessed, we get 16. What if our hypotenuse was 11 square root of 2? What would we have to do to get smaller, right? And that's right, we would divide. We would divide by the square root of 2, and we've got 11 and 11 are 2 lengths. So see how nice and simple that is? Just saves so much time and energy. What if our hypotenuse was 8 square root of 2? x squared of 2. Then our legs would be, yes, you guessed it, divide everything by the square root of 2. They would just be x, right? So that's just a really good way for you to remember the relationship between 45, 45, 90 and the links. Okay, so let's move on to 30, 60, 90. So we like to think of it as, I think of it as 1 square root of 3, 2, right? So we have a squared of 3, and 2a. And that is always the relationship whenever you have a 30, 60, 90 degree triangle. Okay, and I just want to let you know that the square root of 3 times a is actually a smaller number than 2 times a, right? So that's the relationship there. A is going to be the smallest, and then 2a is going to be the largest, and a squared of 3 is going to go ahead and be the middle, all right? And so just keep that in mind. All right, so if we take a look at a triangle, that's a 30, 60, 90 triangle, there's a theorem that says opposite the angle is always the side. So if the angle is the smallest, opposite the smallest angle will always be the smallest side. If the side is the medium, opposite this medium angle will be the medium side, and opposite the largest angle will be the largest sides. And that's always true, and is actually always true in any triangle, not just in a right triangle. So always look for your biggest angle, that'll be your largest side opposite, and your smallest angle, that'll be your smallest side opposite. The trick with a 30, 60, 90 is if you don't have the 30 degree side, always get the 30 degree side first, all right? Because everything stems from the 30 degree side. If you know what A is, then you can multiply by the square root of 3, or you can multiply by 2, and you can get those other two links. Okay, so we're gonna start with this triangle right here. So take a look at where 30 degrees is, and look at opposite 30 degrees. See that 8? That's the smallest side. So if we want to get bigger, we're just gonna multiply by 2, and that'll give us the hypotenuse. If we want the medium side, we're just going to multiply by the square root of 3, and now we have this 60 degree side. And there it is. There's that relationship of 30, 60, 90. Let's try it again. So notice, oh, look at that. We don't have the smallest side. Right now we have the largest side. We have C, the hypotenuse. So our goal is to go ahead and get smaller. We want the smallest side, right? So if we have 2a right now, we just want a. So we're going to divide by 2, and that means we're going to get 6. And now that we have the smallest side, we want the medium side, so we're going to multiply and get 6 squared of 3. Okay, moving on. Again, a squared of 3 to a. Let's do a few more, just so we get the hang of it, make sure that we're good, right? So let's start first with, oh, tricky. Okay, so notice what side you've been given here. You've been given the 60 degree side. You've been given the medium side. And one of the mistakes people make is they go from the medium side and they want to multiply this by 2. No, you don't want to do that. You want to go back and you want to find the smallest side. So if 4 squared of 3 is the medium side, then you want to divide the square root of 3 out, and you get 4 is going to be the smallest side. And now from here, you can double that, and that'll give you the largest side, which is 8. Okay, moving on. What happens if we have, again, a medium side, and it's 11, not 11 squared root of 3, just 11, right? Same concept though. We want to go ahead and we want to divide so we can get smaller. We're going to go ahead and divide by the square root of 3, and so the smallest side will be 11 divided by the square root of 3. Now that we have a, now we can double it, and we get that times 2. Now you can take the moment and you can simplify it if you want. So multiplying top and bottom by the square root of 3, we get square root of 3, 11 over 3. That's fine. Go ahead and leave it that way. And then also we get 22 square root of 3 over 3 for just some simplification. All right. And so finally, how is this working? So remember the Pythagorean theorem. We are doing all of this so that we don't have to do a Pythagorean theorem or right triangle trig every time. And so if we took a squared and then that middle side squared, and we set it equal to the hypotenuse squared, and we simplified this out, we would end up with 4a squared. And if we did it to the other side, we would also get 4a squared. So notice it satisfies the Pythagorean theorem. All right, hope this helps. And I'm guaranteeing you memorize these guys, and it will serve you all the way through calculus and beyond. All right, one of those life skills. All right, take care.